In this video, we are going to see tube cyclic analysis. So let's import the geometry part, which is over here, and then which is actually 3D and deformable. So let's import the part. So now since we have the part, this is a single part analysis. So let's get into the property. I have already created the property, which is in steel. So I have created it. Insert business directory. You can see the property. Edit. So you can see the young smallest and Poisson ratio. I have given a plastic data of a combined one half cyclic. So which cycle hardening I have given. So you can see over here. So Q infinity. So based on this, we are going to run the analysis. Okay, right. So now we'll create a section homogeneous and then go and then apply on it. Done. We have created one. So let's get into assembly. It's a single part. Let's put it in independent and then score in and then let's go to step. So now over here we are going to create static general and then we are owning it and then we will give this and then our timeline is 185. Okay, increment. Let's check over here. This comes up to 0.5. Let's start with that and then let this 1.0 e power minus 5 and then let this be 0 to move the power zeros for it. Okay, then okay. Now let's go to interaction. So I'm going to create two sets on this. So let's see over here. So features like sorry tools sets create boundary condition area. So I'm just going to take this face as PC for thing and then I'm going to create one MPC. So coupling. So before that I need a reference point. I'll take this as a reference point. So now I'll take a coupling and create this as a reference point. Done. And then surface region that we're going to take this. Done. Okay, so thus we have created a coupling. So now I'm going to take tools set create RF. Okay, let's take this. Okay, done. Now let's go to load that we won't get into it. So let's create one boundary conditions that we want, which is in zero step. And we'll incast it. We have the set. So BC continue and then incast it done and then we will create one angular displacement rotation which is on step one, right? Okay, so continue with this reaction force highlight, that is that, continue and then we are going to use u2 for 1.5 times, right? Okay, so we need to create an amplitude of a curve which it will be cyclic. Okay, now they continue and then we have this. So I have already opened like three types of amplitude that we can use for this analysis. So first amplitude is simple sine wave that goes up and down, and then amplitude 2, so which has a higher frequency at the start and then goes to lower, and then vice versa on the amplitude third. So now we are going to use this first curve that we want. So just click and then paste it out and then do OK. Now we have the amplitude one. Let's OK, go for it. And then we'll go for meshing. Now this will be the meshing. Let's take everything, right? Okay. Go for 2 mm, that will be way better. Apply OK and then apply yes, since it's a single piece, so it takes directly and then let's design. No, okay, done. And then this is standard linear, right? Whatever it is, that's good to go, right? Okay. So since this is a solid, it's better have to good thing. Okay. So then we will go to step. Okay, so as soon as you reach the step one sec, we will go to mesh again. So over here, tools, surface, create a set, create a node. Okay, so we are going to create a node for it. So node, take any node that you can see over here. Okay, so you have created a node for it. So get to step. Now we are going to create a history with a reference of a set. So we are going to call the boundary condition. Okay. So the boundary condition, not the energy that we want. We want is a reaction force, that is RF. So especially RF2. So that's what we want. Okay. Just go to do okay. And then um, sorry, what we have, right? Okay, again, create new one, so we can give us, since that is old model, let's click okay, and then create third one, so which will be like set again. So a reference point that we have created, reference point. So uh, so on that you can actually create a YouTube. Okay, at the same way, create you have created one more set for the node that we have taken, set 3. Yeah, set 3 again, displacement U2, right? Go for it. Okay, dismiss, and then just go to job. Now we have everything. Now let's create, what shall we create? Pipe, cyclic, right? Okay, let's create a parallelization of 3, and then let's sum it out. Check with the monitor how it runs. Now you can see the analysis has been completed. So let's just check with the results. So, so this is how it actually creates. It's pretty much, you can see that it's fast. Let's reduce the speed. And then you can see that which is the harmonic thing that is going on. So stress, you can see the strain that which happens. And over here, yep, pretty much deep. So let's check with one more thing that we need to look for it. So history ODP and then get in. Pretty much you take all the uh, boundary condition that you have created over here, that we have created here early sets, right? See as you can see reaction force underscore u2. Okay, underscore u2, and sum it up, because like it's a lot of curves that you have created. So once you sum it out, you can create a displacement node that you have created one. So save as uh, u2. That's it. Okay. Save as u2 and then get into over here. So we are going to operate on xy, and then you can see a combine option which actually minus double click on u2, and then This reaction forced by giving comma. And then double click on that. So you will have save as, let's consider a case hysteresis. So plot the expression that you get a curve of hysteresis loop, which you actually get depend upon the functionality. So it also differs based on the message that you use, right? Okay. So that's it. Thank you.